6 months ago, I made a decision that I had been putting off for years. I took my main gaming PC, a machine I had built and tuned over 3 generations of hardware, and I wiped Windows off of it. I installed Linux in its place, not as a dual boot, not as a secondary system for tinkering, as the primary and only operating system on my primary gaming machine. I did this because I wanted to know, from personal experience rather than from benchmarks I had read, whether the claims about Linux gaming performance in 2026 were accurate. What I found, over the 6 months that followed, is that the claims are accurate, and, in my specific case, they undersold what actually happened. My average frame rates across the games I play regularly increased by approximately 40%. My system's responsiveness improved across the board. The noise my machine produces, measured in terms of both fan activity and the overall feel of operation, decreased substantially. The hardware I was using did not change. The games did not change. What changed was the operating system, and the changes the operating system enabled. I want to walk you through what I did, what I measured, why the performance improved so dramatically, and what a reasonable reader should take from my experience. Let me start by describing the hardware and the setup, because the results depend on the context. My machine, before the switch, was running Windows 11 with all the standard Microsoft components active. The processor is a recent AMD Ryzen. The graphics card is a recent NVIDIA RTX. There is 32 gigabytes of DDR5 memory, and the storage is a 2 terabyte NVMe drive. The machine was well maintained. Drivers were current. The operating system was fully updated. I had made the typical privacy and telemetry tweaks that I recommend to others, but otherwise the configuration was what a typical enthusiast gamer would have. The games I play regularly span several genres. I play a lot of competitive shooters, where frame rates and latency matter most. I play some adult single-player games, where visual fidelity and smoothness matter. I play a fair amount of older games and indie games, where compatibility and responsiveness matter more than raw performance. I play some emulated games from older consoles. I stream occasionally, which puts additional load on the system. Before the switch, I ran benchmarks on my standard set of games. I recorded average frame rates, frame time consistency, loading times, and subjective smoothness. I did this not because I was expecting to write about it, but because I wanted a baseline before making a significant change. Having the baseline was what allowed me, 6 months later, to describe the changes in specific, rather than vague terms. The Linux distribution I installed is CachyOS, which is an Arch-based distribution focused on performance optimizations. I chose it because I had researched the options and concluded that CachyOS's specific kernel configurations, scheduler choices, and default installed software aligned with what I wanted from a gaming-focused system. Pop! OS, Nobara, and Bazzite would have been reasonable alternatives. For users less willing to tinker, any of these 3 would be easier choices. For me, CachyOS was the right balance of capability and polish. The installation process took about 30 minutes. The partitioning, driver installation, and initial configuration were straightforward. NVIDIA drivers, which were historically a point of friction for Linux gamers, were handled automatically by CachyOS's installer. The specific NVIDIA proprietary driver version that matches my card was installed, and the configuration was optimized for gaming. Steam, Lutris, and Bottles were the 3 applications I installed for gaming. Steam handles most of my library through Proton, which is Valve's compatibility layer. Lutris handles non-Steam games, including a few legacy titles I keep playing. Bottles handles some specific non-game Windows applications I use. Between these 3 tools, every piece of software I care about runs well on Linux. The games I tested were the same ones I had benchmarked on Windows. The results, averaged across multiple sessions, showed substantial improvements in almost every case. In the competitive shooters, frame rates increased by between 20 and 50%, depending on the specific game. The improvements were not uniform. Some games showed minimal change, others showed dramatic improvements. The games that showed the largest improvements were typically the ones that were most CPU-bound on Windows. because the Linux scheduler is more efficient at getting work to the CPU cores than Windows scheduler in the specific patterns these games produce. In the AAA single-player games, frame rates increased by a smaller but still meaningful amount, typically 10 to 20%. The improvements were less dramatic because these games are more GPU-bound, and the GPU performance is comparable across platforms. Where Linux showed an advantage was in frame time consistency. The minimum frame rates, the 1% lows that determine whether the game feels smooth, in its worst moments were noticeably better on Linux than on Windows. In the older and indie games, performance was generally excellent. These games rarely pushed the hardware, and the operating system's overhead is a larger proportion of the total work. Linux's lower overhead meant that games that ran fine on Windows ran slightly better on Linux, with lower latency and more consistent timing. In the emulated games from older consoles, Linux showed substantial advantages. The emulators I use are developed primarily by the Linux community and run better on their native platform than on Windows. Specific emulators that were noticeably smoother on Linux included the Yuzu alternatives for Switch emulation and the RetroArch cores for various classic systems. The streaming performance was also meaningfully better on Linux. OBS, the streaming software I use, has native Linux support that is well optimized. The encoder overhead on Linux is lower than on Windows for the specific encoder I use, which means I can stream at higher bit rates and resolutions without frame drops on the game side. Beyond the specific game performance, the system-level responsiveness improved across the board. Application launches are faster, window management is snappier. The system does not have the occasional multi-second pauses that Windows sometimes has when it is doing background work. The overall feel of the machine is more fluid. The noise reduction was unexpected. My machine is not particularly loud to begin with, but the fans on Windows would occasionally spin up when the system was doing background activity that was not directly visible to me. On Linux, the fans are rarely active beyond baseline. The specific cause is the reduction in background processes. Windows has substantial background activity, including indexing, antivirus scanning, telemetry, update checking, and various other services. Linux's equivalent activity is much smaller. The reduced CPU activity means less heat, which means less fan activity, which means a quieter machine. Now let me address the question of why the performance improvements are so dramatic. The specific reasons vary by workload. For gaming specifically, several factors contribute. The Linux kernel scheduler is more efficient at distributing game workloads across CPU cores. The Vulkan Graphics API, which Proton uses to translate DirectX, is lower overhead than native DirectX 11 for many operations. The DXVK translation layer has been optimized over years and is in some cases faster than the native Windows equivalent. The Linux driver stack for graphics hardware is, for NVIDIA, and especially for AMD, competitive with, or better than the Windows equivalent. The absence of background telemetry and services means more CPU time available for games. The memory management is more aggressive about keeping game data in RAM. For system-level responsiveness, the reasons are similar. Linux does less background work. The input-output stack has lower latency. The user space and kernel space interaction is more efficient. The result is a system that feels faster for subjective reasons, not just in benchmarks. I should caveat these claims. My experience is specific to my hardware and my workload. Users with different hardware may see different results. Users with different workloads may see different results. The 40% average I described is my specific number, not a universal claim. Some games in my library showed smaller improvements. A few games showed performance that was equivalent rather than improved. None of the games I tested performed worse on Linux than on Windows, but the possibility that some game in some user's library might be an exception is real. There were also adaptation costs. Learning Linux took time. Configuring Proton for specific games sometimes required troubleshooting. A few games that use kernel-level anti-cheat do not work on Linux, and I had to decide whether to stop playing those games or to keep a small Windows partition for them. I chose to stop playing them. Your choice might be different. The cost of the switch, in terms of my time, was probably 20 hours over the first month. Installation and initial configuration were a few hours. Migrating my game library was a few hours. Learning the specific tools and workflows that are different on Linux was a few hours spread over days. Troubleshooting specific issues as they came up was the rest. After the first month, the ongoing time cost is close to zero. I use Linux the way I used Windows, and the system works the way I expect. The lesson I draw from this experience is that the performance gap between Linux and Windows in gaming, which was real in earlier years, has inverted. For most of my specific games and workflow, Linux is now the better gaming platform. Not just acceptable, better. And the magnitude of the advantage is large enough that the switching cost, once absorbed, has been repaid many times over in improved gaming experience. Subscribe for the next video, which is a detailed walkthrough of the specific steps to switch a gaming PC to Linux, including distribution choice, installation process, NVIDIA driver handling, Steam and Proton setup, and Lutris and Bottles configuration for non-Steam games. And in the comments, tell me what games are on your list that you would want to check compatibility for before making a similar switch. The Linux gaming community has done enormous work making compatibility information accessible, and for most games, the information is reliable and current.